G'day, Espresso here, back in the shop, and welcome. The project I'm working on today is a carriage stop, or a micrometer carriage stop for my Colchester lathe. I've wanted one of these for a long time, and I've looked at various designs. There's lots and lots of them out there, so I'm not going to show you the build of this, except to say that I used an aluminium casting for the body of this thing. Now, typically they're made of steel, some sort of tool steel or high quality steel. I don't have anything the right size, and I'm too lazy to go and buy anything, so I made a 3D printed pattern, two-piece pattern, and I cast that just a normal sand casting. And I'm going to give a shout out here to a gentleman called Old Foundryman. I'm going to put a card up here. If you are interested at all in casting with alloys, check him out. He lives down in Melbourne. He does an excellent job on all his casting. He has some trade background in this area, but the best thing is that if you ask him a question, he will give you a very, very thorough answer. So check him out, Old Foundryman. I adopted a lot of the techniques that he uses for this casting, and it's come out really well. There's very little porosity, it machined nicely, and there was very little shrinkage on the part. Now, as I said, I'm not going to show you how to make this carriage stop because it's just all straightforward machining processes that I've used here. What I am going to do is I'm going to show you how to make, or how to engrave, the dial that goes in this space here. Now, I was getting all ready to do this video, and the machining ninja himself, Stefan Gotchwinter, uploaded a video just recently showing a process that he uses for engraving indexing marks on his parts. And the technique that he used is, we made use of his mill as a shaping machine. He used a single point cutter to index, or at least make the engravings for the index marks. And then he used a pantograph engraver for engraving the numerals. Now, I don't have any of that stuff, so the technique that I'm going to use is just using equipment that I already have. So we're going to do this on the CNC mill. I've got a CNC 4th axis set up, and we're going to use a diamond drag engraver. So once this process starts, it just does the lot. It does the indexing, engraves the marks, and engraves the numbers all at the same time. Now, the piece that I've got for the dial is mild steel. I've chemically blackened this mild steel section here. There's a part screwed onto the end here, and you'll see in a minute why I need this. And I've left it attached to its stock so that I can grip it in the 3-jaw chuck on the 4th axis, and that'll be machined off later. Okay, so let's go over to the CNC mill and get this set up, and I'll show you the process. Oh, hang on, I better change this first. Okay, the diamond drag engraving tool that I'm using is one that I bought on eBay. I think it costs about 100 Australian dollars. It came from England. It's got comes with a spare stylus, and the stylus, in this case, this one has a 90-degree tip, and the stylus is spring-loaded inside the body, so that it's got about 8 millimeters of travel. When the stylus tip comes into contact with the work, it will keep pushing up into the body, so there's no danger of breaking the tool unless you overdo the travel. It also means that you get a constant force of the stylus against the work. It's not really a cutting process, it's more like a forming process, like knurling. And as well as forming an impression in the work, it also raises a very slight burr. Now, you can stone that burr off. I'm not going to in this case, and you'll see why later. At this end there's a socket head grub screw, and you can use this to vary the spring pressure on the stylus. So I've got this wound as far as it'll go in, because I'm working on steel. If you're working on softer materials, you might want to decrease that spring pressure. Okay, I've got the piece set up in the 3-jaw chuck on my rotary axis. This piece of bright steel that I've got clamped on the end of the dial here is an insurance policy. What I forgot to do was to leave some extra material on the dial so that I could engrave almost to the end and then machine off the excess later. Because I forgot, I've made up this piece and clamped that on there. And that's just so that if for some reason I was to overrun the part with the stylus being spring-loaded would shoot out of there and I'd lose the tip, or worse still, it might drag backwards and bend the stylus. So this is just to give me a little bit of room to overrun that end if something goes wrong. I've actually already run this G-code on a piece of scrap, and I sort of know that it works. So I'm not too worried about it. It was more about just it extending under the spring pressure and getting caught. So let's go ahead now and run the code and watch it all happen. Okay, so you can see it's got back to its starting point there. It's cut 50 divisions. Each division represents 0.02 of a millimetre of travel in the stop. The reason for that is that I cut a 1mm pitch thread on the stop. And although I've engraved these numbers here, the numbers themselves don't really mean very much. You simply are counting the number of divisions in most cases, because it depends on whether you're moving the stop in or out of the body of the carriage stop. So you can see it has left a slight burr there, but I'm okay with that. If you really want that high precision look, like I said, you could stone that off and then maybe fill those engravings with black wax or black paint or something like that. Okay, so let's get this out of here now and get it finished off and put it in the machine. Okay, well, with these parts now finished, I'm just going to do the assembly on this. It's pretty straightforward. There's a socket head grub screw fitted up inside this threaded hole underneath, and it protrudes through into the bore with a 3mm pin, and that engages on a keyway which has been milled in the bottom of the, what would you call that? The stop pin, I guess you'd call that. I don't know what its correct name is. Anyway, that slides through and engages on that pin, and the dial has a drill hole in the face. Now, I was a bit concerned that the fit of the dial inside that slot wouldn't be perfect. You've got to have some clearance, and what I wanted to be sure of was that the stop was always pushed up hard against this shoulder here, so that when the carriage comes down and hits the end of the stop, it's already fully engaged against that face there. So the idea was that I was going to fit a spring into that hole and then a ball bearing, so that it just gives a bit of preload against that face. So just got to be a bit careful that nothing flies out here. So the ball bearing just pushes back, and that sort of just keeps a little bit of preload against that knurled face against this back edge of the stop. And then you just simply find the threaded hole and I won't bore you, but you can wind that all the way through. There's a steel plate that fits underneath, and I've just relieved this face of that steel plate, so when the M6 screws fitted. So you can see there that there will be a little bit of movement for that clamp to pull up hard underneath the bed of the lathe. Now, just for a bit of fun, I decided to engrave a logo in the top face of that aluminium casting, and surprisingly it turned out awful. The problem is that these diamond engravers, they work better on hard materials, so hard steel, hard brass, that sort of thing, but certainly on aluminium and this particular grade of aluminium casting, it sort of plows its way like a super tanker through the sea. Basically it just raises this massive bow wave of material as it pushes through. I don't know whether reducing the spring pressure would make a difference. Looks okay, but when you look really closely, the detail's not there. Now I'm going to go and fit this to the lathe, just show you what it looks like when it's fully assembled, and then I'm going to talk you through the process for doing the artwork for this engraving, and it's not quite as straightforward as I thought it was going to be. So I'll go and fit this, we'll have a look at it, and then we'll talk about all of the CNC stuff. So there we go, that's locked to the bed of the lathe now, and effectively what you have is a hard stop for the carriage. Now although this is micro adjustable via the dial there, I'm not so sure that's a really important feature. I'm guessing that if you have a DRO, what you're going to do is to define the feature that you're machining, zero out your DRO, and then bring the carriage stop up hard against the carriage. And that's going to allow you to repeat that position indefinitely. I'm guessing that you can make small adjustments if you really need them. Now, just to wind up here, what I wanted to do was to show you the process that I went through to generate the toolpath for the numerals. Now, I'm going to admit here I feel a bit foolish because I'm going to show you what I did to create the numerals on my engraving, and then I'll show you the easy way. I'm using Corel Draw X8 to do the artwork for any engraving jobs that I do. And what I was looking for was a font or a typeface that was simple. And by that I mean I didn't want to have lots of serifs and lots of decorative elements on the text. I just wanted a basic readable numeral that I could see easily, and also that the engraver could carry out in a single pass for each number. Now the font that I used, this one called Simplex, and if you zoom in you can see that it looks like a series of connected straight lines, so even the curves are actually just straight paths. And that's what I used, and I generated my toolpath, and then I realized that the drag engraver was going back over the number twice. It was actually engraving the outside edge of the font, and then it was coming back and it was doing a second pass around the inside, which was a bit strange. Then I realized that if you are to turn off the fill on these numbers, so down here you can show it has a black fill and no outline. So I'm going to turn on the outline and I'm going to turn off the fill. And then when you zoom in you realize that each of these characters is actually a vector consisting of a closed loop. So the letter I, for example, is a closed loop, or actually a rectangle. So the toolpath that is generated by the G-code is going to trace the complete outline. Now what I did, and it might seem a bit strange, but I'll show you what I had to do. I will convert these characters into curves. So this is now a true vector path, and you can see the control nodes there. And then I deleted individual nodes. So I used my shape tool, and I just went around and I deleted the nodes one by one. Now that might seem like a straightforward thing to do, but it's still actually a closed loop. So I also had to cut through the outline. So I used the knife tool, cut through there. Okay, so I cut through that outline there, and then I can delete that node and then work your way around and delete the nodes one by one, which was a very tedious, time-consuming process. But what it gave me was a single vector. So when it engraves that letter I, it's just going to do one pass from top to bottom or bottom to top, doesn't matter. Now, to do each letter in turn, like I say, it was a bit tedious. I'd have to go around and do the entire letter, and what it would end up meaning is that this letter was actually going to be shorter by the time I get around and do all of the outlines. So if I bring a ruler line down here, you can see that the inside edge of that letter S is going to be raised up to reach that top line. And the same with the base line in the letters, so you're going to end up with discrepancies there. Now, having said that, I actually made it work, and I created all of the numerals from 1 through 9 to 0 using that technique, and it worked fine. It worked perfectly. Then I should have had the brains to do this in the first place. I Googled whether there was such thing as a vector stick font, and I found out that there was. And in fact, I'll show you the web page that I went to. It's this one here, and it's called www.mrace.com, and I'll put the link to this in the video description. Now, these fonts are free. I downloaded the zip file and installed all of those on my system. And if we go back to Corel, you can see here's one here called 1 Kanban Stick 1, and if I zoom in on that, you'll see that it is a true vector shape, right? It doesn't have an outline and a fill. And this one here is called 1 Kanban Stick 9. Same thing, you can zoom in on that and it's just a single shaped line. And the advantage of this too is that you can just type in your text no matter what it is. What I had to do here, because I've converted these to curves, I had to save them as DXF files. I had to import them into Kanban, which was the CAM software that I use, and create my toolpath on those. So don't do what I did. Go and find a stick font or a true vector stick font, install that on your Windows or Mac system, whatever you use, and then when you get to Kanban, you can type your text using the text tool. And let's see if we can find that font. There it is there, 1 Stick 1. Type your text and OK, and there it is. So remember, that is a true vector pathway. Using Kanban, I then use the engrave tool, and then I just set my depth increment, my target depth, my cut feed rate, plunge feed rate. That's it, and it generates a toolpath from there. So if we try, let's see, machining, generate toolpath, there it is there. Okay, so that would have saved me a lot of effort and time, and probably would have got much nicer looking numerals on my dial. But there you go, just a little bit of a tip if you're thinking about doing this. Oh, and by the way, just in case you're looking to buy one of these diamond drag engraving tools, I just did a quick search on eBay, and there are a lot more options than when I first bought mine. These are all coming from the USA, and they're relatively cheap, even though you're paying $30 shipping. And this is the Tag Sherline. I think I saw a video about this very early on. A lot dearer, probably a better quality tool, but certainly there are plenty of them available. So there you go. I hope you enjoyed that. I hope you learned something. If you can pick up one of these diamond drag engraving tools, they are great for doing basic stuff. Even if it's just putting your name on tools that you take out of the shop, it's handy for that. So I'm going to wind up here, and I'm going to sit back and relax and enjoy a little bit of that German porn. Hang on, just wait till I check something. Let's make sure the door's shut. Okay, I'm all alone. Let's check it out.
Hey, welcome back.
Oh, I love this guy.
So I bought a kit for a tool and cutter grinder,